Hey students, so in today's lesson, I'm going to be going over radicals and fractional or otherwise known as rational exponents. But first I want to quickly review what radicals are. So let's say we have something like 5 squared. What does that equal to? Well, 5 times 5 is 25. And basically, if you had something like the square root of 25, you are doing the opposite of that. You're trying to figure out what number, when you square it, gives me this number underneath the square root. And that's going to be 5. And this square root symbol here is also known as a radical, which is why we use that word sometimes. So just keep that in mind, that square root is the opposite of squaring. And we can also write square roots actually using an exponent. It turns out that the square root of 25 is also the same thing as writing 25 to the 1/2 power. And mathematicians, for some reason, a long time ago started writing this using this square root symbol, but really taking something to the 1/2 power means the same thing. You're trying to figure out what number, when you square it, gives me this value right here. And so that's something just to memorize, that square root is the same thing as taking something to the 1/2 power. These are the same. And here's the rule that can kind of help us remember this. The square root of anything is the same as taking that to the 1/2 power. So let's do a little bit of practice with this. I'll start with this first example. We want to rewrite the following with a fractional exponent. So we have the square root of x times y. Now I want you to be a little bit careful here. A lot of people might accidentally write something like xy to the 1/2 power. But that actually doesn't work because this is telling us that the 1/2 is only attached to the y and it's not attached to the x. To really be clear that it's also attached to the x, we have to write xy in parentheses to the 1/2 power. Okay, and so that's just a common mistake I see, so be careful. So for our second example, it says to rewrite the following as a radical, meaning we want to rewrite this so it has some sort of square root involved with it. Now, similarly to what I explained with this previous example, some students might look at this and say, okay, it's just the square root of 3 times t. However, this 1/2 is only attached to the t, and so we want to only write the t inside that square root of t, because that's the only thing that the 1/2 is attached to. And so what do you do with that 3? Well, you just kind of bring it in front so it's not underneath the square root. And these are being multiplied, even though we don't have a little multiplication symbol there, just don't have to write it. And that's how you would do an example like that one. So let's go over radicals and fractions where we have an example like this one. How could I rewrite this as a fractional exponent? Well, we're going to be applying that same concept here, that basically everything inside this square root is going to be taken to the 1/2 power, and that looks like something like this. But it turns out that we can actually simplify this a little bit. We have x to the 5th all taken to the 1/2 power, and you may recall that when you have sort of double exponents in this scenario, you end up needing to multiply those two together. And when you multiply 5 times 1/2, you get 5 halves, essentially. And I'll just do a quick review of why that's true. 5 times 1/2, it's written like so. And when you're multiplying a number times a fraction, there's no denominator there, but when there isn't a denominator, you really have something divided by 1, essentially. You multiply the numerators together, 5 times 1 is 5, and the denominators together, 1 times 2 is 2. And that's how we get 5 halves for our exponent there. So the rule, if you kind of want to see it sort of formally written, is whenever you have something to the nth power that has the square root of that, you end up getting that same base value to the n over 2 power specifically. So let's do some examples with that. Here we have, what is the fractional exponent form of each radical, also known as the rational exponent form? So we want to rewrite the square root of m to the third power. Take a minute here and see which of these options you think that might be. Well, our base value m is going to be the same. And so we can kind of eliminate some of the ones that don't have that base m there and sort of pick out the ones that do have base m. I'm noticing these two here. And so between m to the 1/2 power and m to the 3/2 power, we want to know which one that's going to be. And now m to the 1/2 power is just a regular old square root of m, so it has to be m to the 3/2 power. Let's take a look at our second example here. I'll delete the other one with base m because we don't have any other base m's involved. We have square root of 8 to the 5th. Here we have our two examples with a base 8. And looking back at that rule, remember that the square root of something to the nth power means that we need to have the 2 on the denominator of the fraction. And so between these two options here, I can see that this one has 2 on the denominator. That's going to be the one that's correct. Last, we have our two examples with 4 as the base. And which one of those is going to be the correct version of square root of 4 to the 7th power? Well, that's going to be the second option because the 2, again, is in the denominator there. And those are the examples that we're going to go over today with rational and fractional exponents being rewritten as radicals.